mycelium from the forest. That like a little bit of fungus that looks like a spider web. And what kind of did is he brewed that out on some rice. And so we have a dormant version of that white spiderwebby material from the forest. So this is the jewel of this part of vegetable farming or plant farming and natural farming. The IMO2 is like the most special aspect, because a farmer can have on his shelf something that's not going bad, that can inoculate his farm with diversity of microbial life that's going to cycle nutrients in his soil or her soil. So IMO2 is extremely valuable. But with the IMO2, we only have this little bucket, half bucket, a quarter, fifth of a bucket of IMO2, and we got a lot of land to cover. So we can take this, and with the right nutrients and mix and process, which we're going to do all week. The whole week we're going to be making these piles. And it's a really wonderful process, fun, and your smells are going to be engaged, your touch, your senses are going to be used to make proper IMO. We can get this to be 400 pounds of material and not even use this up. And so we have plenty to spread on our land. It's of the same value, and we cause it to go further. It becomes easy because this has some challenge. You have to go out and place it, etc. So on your sheet you have IMO3 with the nutrients you need for IMO3. What do we need? Name it out.
FPJ, BRB.
Alright, we got FPJ right here. Brown rice vinegar right here. Okay, go on.
OHN.
OHN.
SW.
Seawater.
Humic acid.
Humic acid.
And IMO2.
And IMO2 right here. Okay, so this is all the stuff we need. Well, you know, the one thing we don't have, a little measuring cup. We're gonna have 4 groups. It'll be your pile. So if it fails, it's just the 2 of you. If it succeeds, it's all your own victory. No, you're gonna kill it. You're gonna do a great job. But we are gonna break you up into groups so you can make different decisions and have different results, because then all of you learn from 4 different processes rather than just the one. And it's not a competition, we're not worried about it, but we do want to do it well. And there's all these variables that come in. And the point of what we're doing this week in doing this IMO2 is equipping you to understand the variables, so that when you go to make a decision about, perfect. Here you go. When you go to make a decision about how much or what to do or how to change things, you will have this as a bit of a reference. Okay, so we're gonna grab a bucket. We're gonna fill it with water, about 4 gallons, and we're gonna add your nutrients. We're also gonna add IMO2. IMO2 though, what we'll do is we'll make IMO2 in these. We just add a little bit of water and grab a little bit out of each of these buckets, like a handful, like half a handful, like a big scoop, like you're doing, like you're gonna fill your mouth with poi, but not like you're gonna smash it on your brother's face. Half, sorry, that made no sense. About this much, both big pile on your hand, and put it in there. And then what we're gonna do is we're gonna spread that on your pile, kind of mingle that in your pile, before we put all the liquid, because what we don't want to do is not use all our liquid and waste some of our IMO2. So we want to make sure we use all our IMO2, but we might not use the liquid. If we get too wet, we're gonna stop adding liquid. So you're gonna have 4 gallons. You might not use all 4 gallons, or you might get another gallon more and use 5 gallons. We're gonna be able to tell that based on how it feels, and you'll understand that once we start working with it. We'll talk about it together and work. But initially what we need to do is break you up into 4 groups, And what we're gonna do is about, you can choose how much kalo shavings, but about 25% of the total. So rice bran will be about 50, wood chips will be about 50, and then you can bring in about, you know, a third or 25% of the kalo. So what we're gonna do is mingle those ingredients, the dry ingredients, all together before we add water. Get it nice and homogenized or uniform, all dry. Then we're gonna bring in the water with the nutrients, these nutrients in those amounts, and we're gonna mingle those in. And then once that's all mixed, we get it to the right moisture, we leave them sit, and these microbes are gonna grow on that material because it's food they like. The fats and the proteins in rice, the fats and the proteins in the kalo, some of the carbon in the wood chips. It'll chew on that, multiply, and bloom. And so we're gonna have this pile of microorganisms. You're gonna see it blooming. It's gonna get hot, like 110, 120 degrees, and it'll cook for 3 days. No, we're not applying any heat or anything. Just like a compost, but like a compost concentrate with microorganisms. When that finishes, what it'll have is lots of seeds of that white spiderwebbing material from the forest, the mycelium. It'll basically be a pile of seeds of that organism or that type of organism. So then if we want to apply it, we put that, and it's like applying seeds of like cover crop or grass or whatever. It's gonna bloom in our soil. But then we'll make another stage with, we'll make another stage, we'll mix it with soil, and we'll do it again. So that's IMO4 when we mix with soil. Today we're making IMO3. And if you understand the variables of this, then making the IMO4 is pretty easy. So this is about understanding how high we pile it, how much moisture we use, how much wood chips we use, and how that affects how it goes. What we can't have it do is get too hot. So the whole time we're making this, we're keeping it from going past 120 degrees. If it goes to 130, it'll start to smell like ammonia, like a kind of a negative smell. And it'll stop producing all that diversity and just produce one thing. So we keep it in the like 110, 116 range, and all those organisms grow on that substrate, and we get a ton of them for use on our farm. Really wonderful material, and you can farm anywhere in the world with that material if you know how to make it. And you can make it on anything. We're gonna make it on kalo, we're making it on rice. Rice is all over the world. You can make it on oats, things with high fat and protein. So today is just mixing. There won't be any temperature today, no heat, but we have to make a lot of our choices today. How wet do we make it? How high do we pile it? How much carbon do we use? As we get going, we're gonna talk about how to make those decisions. But this material for like a 50-pound bag, I would value at about $500. So between $500 and $1,000 if you were to buy it off the shelf. And you're learning how to make it with a $20 bag and some water. But it has a lot more value than that to a farmer who's producing with it, because it can help your nutrient cycle. So part of this is for your education, to understand nature, to understand it deeply in your now. Part of it is that you can make a living with this knowledge, whether you farm or you help farmers farm. This is really valuable knowledge and tools.